Independent events. Two events are independent when the outcome of the second one is not affected by the outcome of the first. So some examples of that is if you roll a coin and then if you toss a coin and then you toss a coin again, your probability of getting heads or tails does not depend on what you got the first time. If two events A and B are independent, then the probability of them both occurring is the product of each individual probability. So let's look at a few examples and just determine whether they're independent or not. So a member of the junior class and a second member of the same class are randomly selected. Is that independent or dependent? Since they are being selected from the same class, this is actually dependent because since two people are being chosen, the denominator is decreasing. So that would be dependent because you can't vote for the same person twice. So it depends on who got chosen first. A member of the junior class and a member of another class are randomly chosen. So for this one, it's actually it's independent because whoever you choose from the junior class is not going to affect who's chosen from another class because they're in separate classes, so they don't affect one another. For this last one, an odd number problem is assigned for homework, and an even number problem is picked for a test. So this one does not, this is independent also because whatever odd number you choose for your homework is not going to affect an even number that's picked for your test because odd and even, those are what you call exclusive. They don't overlap. Either you're odd or you're even, no in between. Let's do an example. A bag contains 4 red, 4 green, and 7 blue marbles. 3 are selected at random in a sequence without replacement. So a key term here is without replacement. Without replacement automatically lets us know that it's going to be dependent because your denominator, what you're choosing from, decreases every time. So what is the probability of selecting a red, then green, and then red in that order? So the first thing that we want to do is we want to apply our rule for independent events, which is just we take the probability of each of them and we multiply them together. But since they're dependent, we have to be careful with our numbers. So the first one is easy. If we try our first try, we have 4 red marbles and there's a total of 4 plus 4 is 8. There's a total of 15. So we have a 4 out of 15 chances our first time of getting red. Now for the second time, we still have 4 green, but there's a total of 14 marbles now because we took one red one out. So now there's only 14. For the third one, how many red ones do we have? We have 3 because we already took a red one out. And now there's a total of 13 because we took a red one out and a green one out. So when you do that, you would just have to use your calculator to find what the final answer is because I don't have mine, unfortunately. But yeah, that's how you would do that problem. Just be careful that when you put it in your calculator that you put parentheses around your fraction. That is very, 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 very important. Next example. 7 books are on the shelf, 4 are algebra and 3 are geometry. A student selects a book at random and replaces it. Replacement indicates that it's going to be independent. So our denominator is not going to change because you're taking it out and then you're putting it right back. A second student then selects a book at random. What is the probability that both books, so that means that we're choosing 2, are algebra books. So how many are algebra? There's 4. How many total books do we have? 7. So our first time we have a 4 out of 7 chance. The second time, since we replaced it, there's still going to be 4 algebra books and there's still going to be 7 total books. So that gives you 16 out of 49. And you always want to check to make sure you simplify when you do these. Next example. A green die and a red die are tossed. What is the probability that a 4 shows on the green die and a 5 shows on the red die. Well, we have to think about how many numbers are on a die. And there are 6. So our denominator is 6. We have 6 choices for our green die, and we know the probability that a 4 shows. Okay? So there's only 1 4 on the die. So it's a 1 out of 6 chance that we roll a 4. And on the next one, there's a 1 out of 6 that we roll on the red die. So when you multiply that, you get 1 out of 36. And these events are independent because whatever you roll on the green die does not affect what you get on the red die. Thanks for watching.